In this video, we will talk about natural logs. A number like pi, as we know, is approximately 3.14. We have another number just like pi, e. E is approximately 2.718. In both of these cases, these numbers cannot be written in fractions, so these are called as irrational numbers. Numbers that cannot be put into fractions. E is a very special number because when we use the log base e, when we use e as a base, log of e is the same as ln. So log of e of x is the same as ln of x, which is called a natural log. So whenever we have a log with the base of e, these are called natural logs. Let's look at the graph. Y is equal to e to the x. E is just like a number, so y is equal to 2.718 raised to the x power. So if we plug in x for 0, a number raised to a 0 power is always equal to 1. So it's going to cross at 0 and 1. And then when x is equal to 1, it's e, a number e. So it's going to be 1 and e. And as you can imagine, as x increases, the number y will increase as well. So it's exponentially increasing. And if you look at what's on the left side of the y-axis, the number gets really smaller and smaller and smaller, right? Because it's e raised to the negative first power. That does not mean it's a negative number. It means e to the negative first power means 1 over e. 1 over e to the third power, 1 over e to the 10th power, right? As we can see, 1 divided by a bigger number is going to get closer to the 0, but it's not going to be quite 0. So the asymptote will be on the x-axis. So y is equal to e to the x. If I want to solve for an inverse of this function, we would change x and y, so this becomes x is equal to e to the y. We need to solve for y, so we need to take the ln on both sides. So ln of x is equal to ln of e raised to the y. So using the laws of logs, we can say ln of x is equal to y ln of e. Ln of e is actually 1 because ln means log base e of e. So e raised to the what power gives you e? 1. So this whole thing actually is equal to 1. So we already have solved for y. Y is equal to ln of x. That is an inverse of y is equal to e to the x. So now that we know generally the general idea of the inverse of y is equal to e to the x, let's look at the graph. Inverse always reflects on the y is equal to x line. And then coordinates of x and y, they always switch. So in this case, 0 and 1 becomes 1 and 0. 1 and e becomes e and 1. If we were to plug in the numbers, that'll also be true. If we have 1 for the x, it becomes ln of 1. What is ln of 1? It's a log of e of 1. E raised to the what power gives you 1. Right? A number raised to the 0 power gives you 1. So it has to be 1 and 0. If we have ln of e, let's check y is equal to 1. So ln of e means e ln log base e of e. So that has to be 1. So this is also true. We'll look at more on the next slide. Here we have ln of 1. ln means log base e of 1. So then, how can we simplify this? What is this number? E raised to the what power is equal to 1? X must be equal to 0 because a number raised to its 0 power is equal to 1. So ln of 1 is actually a 0. What about ln of e? This means log of base e of e. What is this number simplify to? If we let this to be y, e raised to the y power is equal to e. In order for them to be the same, this really has an e raised to the first power. So y must be equal to 1. So ln of e simplifies into 1. Alright, so ln e to the x. What is that equal to? Well, ln means log base e of e to the x. So if I let this to be equal to m, this means e raised to the m is equal to e to the x. What is m equal to? X. So ln e to the x is equal to x. Another way to look at this one is ln e to the x. Using the laws of logs, we can pull out the x in the front. So x ln of e, but we already know that ln of e is equal to 1, so this must be just x. Right. Last one, we have e raised to the ln of x. If we let ln of x to be y, so ln of x is equal to y, then we can rewrite this in an exponential form using, well, ln means log base e of x is equal to y. So writing into an exponential form, that's the same thing as an e raised to the y is equal to x. Right? So combining all these things together, e raised to the y power is equal to x. But y, again, is equal to ln of x. So e raised to the ln of x is equal to x. So e raised to the ln of x, the answer to this is equal to x. So in both of these cases, right, the answers were equal to x. ln of e, it's kind of like undoing the function, right, because y is equal to e to the x and y is equal to ln of x. They are inverses of each other. So it must be undoing one another. Same idea, e to the x. This is equal to ln of x. So you're undoing the function, so they must be equal to x. We briefly talked about this in a previous slide. Laws of natural logs are exactly the same thing as the laws of logs. If we had log base e of a plus log base e of b is equal to log of base e of a times b. Right? But we know that log of e is equal to ln. So we can say ln of a plus ln of b is equal to ln of a times b. Same thing. Ln of a minus ln of b is equal to ln of a over b. And then if we have n ln of a, this n goes in as an exponent. And make sure that it's inside the parentheses of ln. So ln of a to the n. So the laws of natural logs is kind of the really same deal as the laws of logs. Let's try a couple problems. If we have 3 ln of 2, that means this 3 goes it as an exponent. So we really have ln of 8, because it's 2 to the third power, plus 2 goes in as an exponent here, so it's ln of 5 times 5, 25. In that case, it's ln of 8 times 25. What's 8 times 25? It's 200. So ln of 200. Alright, so what about the second one? This 1/3 again goes in as an exponent. So ln of 8 raised to the 1/3. Well, 8 is the same thing as a 2 to the 3rd power. Raise the whole thing to the 1/3 power, right? So it's actually just a 2. So ln of 2 plus ln of 3 is equal to ln of plus, so you multiply, so it's just 6. Last problem, we have negative ln of 1/2. This negative really has a -1, so if it goes in as an exponent here, and make sure they're all in the parentheses, we have ln of 1/2 is the same thing as a 2 raised to the -1st power, right? And then we're raising that again to the -1st power. So it's a power of a power. So we multiply the exponents. So we're left with ln of 2.